Okay, good evening. Good evening, everyone. So let us start with a new problem today. Now, this is on forces in a spring. So the problem reads a body of mass 100 grams is attached to a hanging spring. Okay. Whenever we start with problems on spring, most of the time I realize that students make a mistake. Let me show you what kind of mistake they do here. Why that is very confusing. Okay. Force constant is given. The body is lifted until the spring is in its stretched state. Now it's an unstretched state. So which means that you lift it upwards. So the new diagram looks like this. Looks like this. So this was the stretched state. This was the unstretched state. Okay. Then the body is lifted until the spring is in an unstretched state, and this mass is given to you already. This mass is given to you. This is your mass. And then this and then released. The speed of the body when it strikes the table 15 centimeter below the strike, the release point. Let us say the table is here. Table is here. Now, the moment you release it, this object goes and hits here, which means the new spring diagram is now like this. New spring diagram is like this. Okay. So the distance between the original and the table, this length, is seen to be 15 centimeters. This is also given to you. Okay. Now, what is being asked? What is the speed of the body when it strikes the table? It will strike the table with a sound, dum, right? Okay. So it's going to strike here with a velocity v. Otherwise, you won't get that sound, right? So which means definitely this option D is incorrect. Thank God, most of the students realize this. Option D is incorrect. Okay, they didn't do this mistake. But most of them either got an answer A or an answer C. Then I asked them, why do you get this answer? And what made you think? So, these are all not random numbers. These are some numbers which are actually given over here, right? So what they thought was they did something like this. Initially, the first thing that they did was you lifted this object, put over here, and then you drop it. When you say dropped, what did they do? You put u equal to 0, first one. U equal to 0, first misconception, u equal to 0. And you want to find the velocity v. So therefore, the velocity v is equal to v square equal to u square plus 2as. Use this formula. U is 0 plus 2. Instead of a, I put g, and instead of h, yes, I put h over here. So that's what do I get here? 2 into 10 into, what's the value of h? 15 centimeter, which is 0.15, which will give me 2 into 10 is 1, 10 into 1.5 is 1.5 into 2 is 3. So this v is equal to root 3. So they get this answer. Okay. So they said this is the way how we do it. Now I asked them what is the role of the spring. They said, sir, anyway you are going to drop it, right? I can easily use this. Which means they have not understood what is the role of the spring in this example. Now you will get this answer v equal to root 3 if the spring was not there. You just took an object, dropped it from a certain height, it fell down, then this method is correct. But here you should not use this. Okay. So the role of the spring should be substantiated. Okay. Now the second method, there were some intelligent guys in my class. Okay. And then they did it like this. They said, sir, the object falls down. The reason is because some spring energy is being present in it. I asked them, what is the spring energy? They said half kx square is the spring energy. Okay, and as a result of this, now when it falls down, the velocity at which it strikes the table is v. So therefore, the kinetic energy of the block should be half mv square. Wow, let us look at this also. Remove this. Now what is x? 15 centimeter. So they found out v is equal to square root of k by m into x. Simple mathematics. So which should now be k. What is k? 100. Sorry, k is 10. 10. What is m? 0.1 kg. Multiplied by x. X, what is x? X is 115 centimeter, which is 0.15. Okay. So thus, what do I get here? 10 by 0.1 is nothing but 100, root 100 is 10. 10 into 0.15 is 1.5. Are we doing it correctly? Yeah, I think this was 15 meters per second. 15, yeah. 1.5, sorry. This was 1.5 meter per second. Okay, 1.5 meters per second. So therefore, they said, okay, answer C is also correct. But unfortunately, both the answers are incorrect. The correct answer is seen to be B. Now let us explore why it is B. The first thing is, so here, what did they do? They thought that the block fell down. Reason is because it utilized all the spring energy. Now we should ask a question. We should ask a reverse question here. The question is that if suppose if the spring was not there and you keep the block, will it fall down? Definitely it falls down. Why does it fall down? Gravity. Gravity pulls it. Okay. But there is a movement there, right? If it has to move, it has to spend some energy. Where is that energy? Who gave that energy? Potential energy, right? Potential energy. Now, did we see the potential energy here? That is missing, right? So here what they have done is, it's only they have equated the spring energy to the kinetic energy, which is once again incorrect. So what principle should I use? The first thing is in such problems, okay, we should decide what principle we have to use. The principle here is nothing but your conservation of energy. Why conservation of energy? Because energy is neither created nor destroyed. Okay, there's no friction here. So you can use conservation of energy. So towards it, when you lifted the block over here, what was the energy? So you read this, the body is lifted until the spring is in unstretched state, which means what? Okay, the spring was not in a stretched position. So it does not have enough energy there, right? It doesn't have any energy. So therefore you lift up this block here, the energy which this mass has with respect to the ground is nothing but potential energy, right? Potential energy. And thus you should be able to write its kinetic energy was 0 plus initial potential energy was mgh. Do you agree? So this is your initial kinetic energy, this is your initial potential energy. This should be equal to final kinetic energy plus final potential energy. What is final kinetic energy? You made this block to come down and fall over here. Half mv square. This is right. Now, while it falls down, doesn't it stretch the string? Right? So therefore, the mass has to do some work on the spring. There's some energy stored in that also. Some energy which you gave here is consumed by the object and it's also consumed by the spring. So therefore, I have to write this as half kx squared. When I say consumed, that means that's the energy stored in it. So half kx squared plus. Now we have written only kinetic energy of the object plus the potential energy of the spring. Now we have to write the potential energy of the object also. What is the potential energy of the object? 0. Because it is this your reference level, right? So it has reached the reference level. So now let us solve this. Okay. So what is known to us? Now what we do is we do it like this. 2mgh is equal to mv square minus plus kx square. It's kx square. I multiplied this by 2 over 1, both the sides. Now let us substitute the values. Now this should be, let me write, start from here. 2 into 0.1 into 10 into h. What is h? 0.15 is equal to, what is m once again? 0.1 into v square. We need to find out what is the value of v square plus k. What is k? K. What is the value of k? 10. 10 into, what is x? 15 centimeter, which is 0.15 square. 0.1 whole square. So which I can once again write this as 0.1 v square plus, this is how much it is? 0.0225 multiplied by 10 should be 0.225. This is what I should get. In other words, now here, what is there in the right hand, the left hand side? This should be 2 into 0.15 should be 0.1, 10, 0.15 mgh, right? Right. So therefore, 2 into 0.10 into 0.1 is 1. 1 into 0.15 into 3 is 0.3. Right? 0.3 is equal to 0.1 v square plus 0.225. This is what we get here. So next what I do is I write 0.1 v square is equal to 0.3 minus 0.225, which is equal to how much? Which is equal to 0.075. Our v square should be equal to 0.75, right? And if you find the value of v, take the square root of this 0.75, which would be 0.86. Thus, the answer is B over here. Okay. So look at the way that though you have understood the concept, but somewhere while you solve a problem, you make a small minor mistake, and as a result of it, this problem, okay, which could be a 3-mark problem or a 1-mark problem, okay, you won't get it correct. Okay, so this for today, I would like to conclude here. So if you like my video, do like, share, and subscribe to my channel for more updates. Thank you.